William Trelawney coming at you from the Service Delivery Department, aka Professional Services at Graylog. Coming at you with a talk today on demystifying Kubernetes for security analytics. The premise of this talk is that Kubernetes is kind of a new and still actively developed cloud platform technology that a lot of our services today are based on, and so while it's very powerful and scalable and great in a lot of ways, one way that I've found in my journey through getting Kubernetes certified is that doing log analytics from your containers and pods is not as intuitive as it might seem, and we'll go over why later on. So in this talk, we're going to go over what logging looks like in Kubernetes currently, what is supported, what isn't supported, the issue with how Kubernetes handles logging, and not that there, I guess, issue may not be the right term, but the lacking features in Kubernetes. And so Kubernetes is a very extensible platform, and depends heavily on other open source integrations and plugins to get things to work certain ways. Like the core of Kubernetes doesn't include certain things that help with security analytics. We're going to talk about potential solutions to how to overcome, how to get logs out of your Kubernetes cluster. And then finally, we're going to give you what I recommend is the best solution, as of now. Like I said, the entire Kubernetes ecosystem is very actively under development. And so a lot of, and by extension, all the plugins are as well. And then yes, I'll show a demo of this live. So currently, logs in Kubernetes are, so if you're familiar with Docker, then you know that every container generates logs. Containers log to their standard out and standard error stream, and those are also can be written to log files. Well, in Kubernetes, if you're not aware, the smallest unit of containerization that you can access through the Kubernetes API is a pod, not a container. A pod has a collection of containers that all produce their standard output, and the logging is done at a pod level. Though you access a pod's logs, which is an aggregation of all the containers logs. But it works the same way. It's just extra orchestration and management layers on top. So the application containers print the logs for standard out and standard error. Pods read the container logs. Logs are accessible through the kubectl logs command, but the operator there is kubectl logs and then the pod name, not the container name. And then all the individual containers logs are written on the Kubernetes host by default at var log pods and then container name.log. And as you can see in the diagram on the right, which I pulled straight from the Kubernetes documentation, there is a log rotation mechanism built into Kubernetes that manages the log file lifecycle. So the problem with this is a fewfold. One, there's no native cluster level logging mechanism. Yes, you can issue the command, kubectl logs to get logs of a pod, but that is one way to get a current stream of logs for that pod. There's no central interface where you can just get all pods and all containers logs in a single stream to be piped, somewhere else. Some of these other enterprise solutions that have that are more like have large deployments, like for example, a lot of these like enterprise firewalls or security devices, they can all report back to a kind of master central control server where you can see a stream of logs from all the different devices. In Kubernetes, there is no such mechanism, and of course, that can be it's considered. I believe that's by design. Kubernetes is designed to be. I mean, you have the control plane, which is kind of the same thing, but it's meant to be a kind of the deployments are meant to be very, very spread out, very, very not so heavy and centralized. And so it's kind of by design, the design of Kubernetes architecture is not very conducive to that kind of mechanism. The other issue is, as soon as a pod dies, you don't have access to its logs. And I know that container logs are written to the host and their own log file. But again, that's just like, you have to know the container ID to know what log file it was writing to, and those container IDs are ephemeral. Pod names are ephemeral, and so if a pod's not running, and you don't have a way to like capture those host log files, then you can't get logs for it. You can't see why the pod died, except you can go through the Kubernetes events API, but that's a separate kind of mechanism. And even if the Kubernetes events API isn't working, then you don't have that. So no pod, no logs. And then because of these, there's no way to really do cohesive application analytics, especially mapping behavioral correlation between one application and its backend database, or different applications. You can't really, there's no single pane of glass for all your entire Kubernetes deployment logs. So it's a very similar problem to what Graylog solved when it was built back in 2010, I believe, about how when you go to a device, you have to cat or tail F its log file to kind of see what's going on. Well, it's the same kind of thing here. There's no Graylog for Kubernetes built in, at least, but we're going to see how we can leverage Graylog for this, though. So a potential solution is you can be kind of heavy-handed and customized. You can every container image, you could modify a container image to hard code log output destinations. And if you have an application and this might work for like completely custom built applications, but if you just want to have like an Nginx proxy running, you're going to use the default vanilla Nginx proxy and configure it to your needs. But the more you configure it, the more bespoke it becomes, and the less supportable it is, and the less or just the harder it is to maintain. And so, but you could build log export directly into your application, though. You need to know how to do that. Modifying container images is not exactly the most common skill set yet, at least. And then, of course, if you change a container image and you have to get the update. Get the latest updates for that container. Well, now you have to make sure that these updates don't break your customizations and vice versa. You have to kind of any bit of customization is just yet another piece of technical debt you have to maintain across all updates for the life of the service. So it is a solution. It's not the greatest, not the most extensible. Solution number 2 is to use host level logging. Like I mentioned, every container writes its logs to a file on the Kubernetes host. And so just like this, in the traditional sense, just like Linux servers, applications running on Linux servers, or I guess even Windows servers, they write logs to a log file, and you have another service on that host that reads those files and ships them ships them to your log analytics platform. Which this is better than the first one, but as you can see on the right, you can't do this if you're using cloud managed Kubernetes like Amazon EKS or Azure KS or Google Kubernetes. So because they provide the Kubernetes control plane, the API, but not the underlying host. And then similar to the previous point, the more you have to modify your host, the more services and agents you have to deploy to your host. That's just yet another piece of configuration maintenance, software maintenance. Each host becomes less default than it was before. And then the third point here, when you stand up a new host, you either deploy this logging agent and its configuration manually, which is more work, or build some sort of automation to do it for you, which is more complex, even more complexity, and that automation itself becomes another piece to maintain in your business your business IT. So again, it is a solution. I think it's probably better than the first one, but still has its downfalls. The best solution which is scalable, does not modify your host, so therefore it can be run in cloud environments, and can can infinitely scale to whatever size you need. Is to use what's called a sidecar container that runs in all pods, aggregates all the pod logs, and forwards them to a central log storage. The kind of Kubernetes object that does precisely this, that deploys a container that runs in all pods, is called a daemon set. So that functionality already exists. So yeah, this helps keeps your pods and nodes idempotent, which means that you can just crash one, spin one up, and the new node will have all the same things that the old one did because of the daemon set. If you don't have a pod, you still have the logs, because these logs were getting exported while the container was running. These logs were getting exported to your log storage the whole time. So pod dies, you can go to your log storage and see, okay, what exactly happened before it died. Because when the new pod comes up, the new containers are completely new container names, new pod names, and so they'll have a fresh new set of logs that has absolutely no relation to the previous pod and previous containers. And of course, just like with any central log storage, log analysis, you'll have a single pane of glass analysis across all your applications, which is the ultimate goal of any log analytics. And so this is all great. How do we do it? What's out there? Do I need to build all this stuff myself? It sounds kind of complicated. What are all the different things I need? Well, fortunately, there are existing solutions out there, and they have decent enough documentation that you should be able to follow through, and that I made the demo for. And I'm going to show you Fluentd, which is probably the best solution for this. It's kind of designed to be cloud native, and Fluentd is just a log collection, parser, aggregation. I mean, if you think of in the older days, it's kind of like the syslog ng of containerized environment. It's an agent you can run everywhere that can collect logs from different sources, and do some parsing and whatnot, formatting to get them into whatever format you want, and then has outputs to send wherever you want. And so on a similar case, and what most of you who have been in the Graylog space and the log analytics space probably recognize that top middle logo as the beats, or file beat specifically. File beat is an elastic stack technology, so not exactly cloud native, but it's been adapted to work in containers. And so FileBeat, I'm kind of showing you that one as well. Fluentd is the one I was going to focus on more, but I did in the process of my research, I did discover that FileBeat does achieve very similar outcome. And the advantage there is that Graylog already has a lot of built-in support and such for FileBeat. Then of course on the right is the Kubernetes, and then of course, being at a Graylog conference, I would be remiss if I didn't use Graylog to show off the centralized log storage and analytics capabilities. So what would logging look like in this new kind of setup? So if you remember the first diagram, you have the pod and the container within it. They write standard out and standard error, which can be captured as well in the actual pod stream, but also they are written to an actual log file in the host. Log rotation works on that. But then you have this other pod that is running on every host that reads that log file and sends it out to the logging backend. That logging agent can have a lot of pre-processing to work on messages as well. It has to know where these log files are. It has to know how to get their names, what format these logs are going to be in, because your applications that are running in containers, for example, the example we're going to use later on is a simple WordPress container, and so it's writing these HTTP logs. Well, these HTTP logs are being generated by the application, but it's still wrapped around. It's an application within a container within a pod. And so the Kubernetes container runtime interface, or CRI, is actually kind of wrapped around these application logs. And so you need this logging agent to be able to understand the CRI log format as well. But either way, I got this diagram straight from the documentation too. So this is all fully supported. This isn't like some super obscure, custom solution that I kind of made up over the weekend. This is all very much publicly available information. So yeah, quick overview. We're going to deploy a Fluentd and a FileBeat daemon set, separate daemon sets. So I'm just going to show off both of them. And a daemon set is going to be deployed to all pods across all nodes. And it's going to collect the standard out and standard error from all applications via their log files. The log collector is going to do basic formatting and going to output basic formatting, referring to interpreting the CRI log format. And they're going to output to Graylog, which is running separately outside of Kubernetes. This could work perfectly well with Graylog in Kubernetes. There's no reason why it couldn't. But as of yet, we don't have an official Graylog Kubernetes Helm chart yet. So hopefully by next Graylog Go, we'll have that and I can show that off. So Fluentd is going to output in GELF format, which is the Graylog extended log format. And it's wonderful that Fluentd supports GELF by default out of the box, which is great. FileBeat doesn't, but that's fine. I mean, it's an Elastic Stack product, so it kind of makes sense. But JSON is fully supported by Graylog as well, and FileBeat will use the log stash outputter, and just like we do with any FileBeat deployment, we have the Graylog server as the log stash output. Graylog is able to do all those same normalization and parsing that it always does, and configure app analytics. And then of course, at the end of any IT project, it's requisite to have a beer. So I won't do that on this though, but as you're watching along, we'll go for it. All right, so for this demo, I have already deployed a WordPress application. I'll just show you what's running. So we have WordPress application here, and then some other helper containers or helper pods running. So what this is all running on my MacBook. This is a multipass. Multipass is developed by Canonical, the same people that develop Ubuntu, and they are very actively contributing to the whole containerization movement. Multipass is a way to run VMs on Mac. They support the ARM. That's right. I'm also running the M1 chip, so I'm running ARM processor. So yeah, it's been a big struggle to find a good, reliable virtualization platform for ARM processors, and Multipass just works flawlessly. I would highly recommend it. But Multipass, we're running one VM, and we're running microK8s on that. And microK8s actually, just to set this up, when you do, if I can actually spell micro, so microK8s is running, and when you actually install microK8s, it has a hook, right? It searches for any hypervisors running on your host, and it recognizes the Multipass hypervisor. So you can just run microK8s. I believe I even have it in my history. Quotes. Yeah, so microK8s install, specify the number of CPUs, gigs of memory, a disk to use for just any sort of transient storage you need. And it'll install and the latest Ubuntu, or latest, I guess. Sorry, this is the latest Kubernetes or microK8s version. Install it. It'll create a Multipass VM called microK8s VM, where you can run all this stuff. So back to then, as you can see, everything's running. This is all running on my Mac. MicroK8s is running a few add-ons to get this to work. By default, it comes with the DNS add-on enabled, everything else except for I enabled host path storage just because the WordPress server needs a persistent volume claim, and in order to do that, it needs to have some sort of storage medium deployed for the VM. So I have that enabled, and then to serve for the WordPress UI requires a Kubernetes service called WordPress, and for that to get a reachable IP from my MacBook, need just a metal LB installed with zero configuration. So it'll just take the multipass VM IP address and allow any services to map to that. So, super like no configuration other than enabling these two add-ons. So it's pretty vanilla. Should be able to reproduce this yourselves easily. But so here I have a few manifests, Kubernetes, and a manifest in Kubernetes is a YAML file that defines an object, and objects can be anything. Objects can be what I call here CMs are config maps, which this one here. This is basically a config map is just this configuration part here, the data part. And I'll get into why this one in particular. Fluentd. This is how I'm going to tell Fluentd what log format to expect when it's reading, because you can use Fluentd with anything. It's not strictly for Kubernetes. It has native support for it, but this is how I'm going to tell Fluentd what type of log format to expect. Very simple little configuration here. Parse type CRI. And so this is a config map I have, and then for FileBeat, a similar kind of thing exists. But for FileBeat, FileBeat supports auto discovery, and so that's required. So instead of telling, it's required to to auto discover new container logs from Kubernetes. So Kubernetes is a provider of what's called hints, and FileBeat listens for those hints to see, okay, yeah, here's the node name, Kubernetes pod names, Kubernetes container ID, like as the name of the log files. So here's the var log containers, which I know in the previous slide I said that they exist in var log pods. Containers is a one symlinks to the other, so it's pretty much synonymous. And then a few other things. I got this straight from I believe it was Logstash documentation. I'll put links to everything I have in the final presentation that we publish. So you can have all those references too. But like I said, everything I got here was from public documentation. None of this was like just me custom writing anything. But the rest of the, this is essentially the filebeat.yaml file that every FileBeat deployment needs to have. So it has these things. I actually don't use any of these. I leave them blank, but I left them in there just to leave this as default as possible. And same with the output Logstash. This is just like with any other Graylog deployment. These are defined in the FileBeat daemon set. So that leads me right into this. So a Kubernetes daemon set, like I mentioned before, is a pod that will be deployed on every node, and if a pod dies, it'll be redeployed. It's kind of like a daemon set is an object in Kubernetes that says, a pod or multiple pods must run on all nodes. So it's very simple, and that's kind of how the Kubernetes verbiage works. It's like with a lot of other things, you create configurations to say, like, here's how the application should behave. But with Kubernetes, it's more prescriptive, saying this is what I want the end result to be. So it's kind of a subtle difference, but it's actually really powerful way that Kubernetes handles these things. It's like, because the Kubernetes API is always checking to make sure that its current state matches the desired state, and so that's how the daemon set is able to work. But a daemon set has a couple of prerequisite configurations underneath of it. I won't go into them too much, but basically you need a service account, and a cluster role, which is is a set of permissions for a set of permissions on the cluster. You can get, watch, and list all the namespaces, pods, and nodes. And then a role is not a cluster wide role, but this is just another set of permissions to have. Again, I got this straight from the documentation. And then cluster role binding is tying a role to a user, a service account, sorry, tying a cluster role to a service account, and then role binding ties a service account to a role. So all these kind of prerequisite things. And then here we get to the daemon set itself. I create a separate namespace for these logging pods called logging. Just kind of best practice to keep different aspects of your deployment in their own namespaces. And a lot of basic things, Kubernetes app file beats. And again, this was straight from documentation. I did change this, the DNS policy, cluster first with hostnet. I found I had to change this just based on the way microK8s works. So you might have to add that as well. Then you see here, it uses the latest file beat, 8.15 at this time. Then here, the environment variable of log/host has a value of graylog01.lab, which is the host name of my Graylog lab, and then the port here. This is what I had referenced in the config map, which the config map is pretty default. This is the only piece of customization you really change here. Basic resource limits, volume mounts. This is where I mount the file beat YAML as well. And data, all the container logs, as I'm actually not using Docker containers, but like I said, this is pretty much just default configuration. And then the one piece that I had to modify here is this is specifying the config, for the config volume mount, I specify a config map for that volume. And the config map is the file beat config, hence config map, if you followed all that. So basically what that file I was showing you previously, that is what's going into etsy/filebeat.yaml. And then, yeah, the host varlog volume is being mounted into the containers the way FileBeat can read it. And then we'll do the same thing for the Fluentd daemon set. Same thing, service accounts, bindings, daemon set here. A lot of the same things except with some, Fluentd changes. We want this to run on the control plane nodes, which it does by default. With this being microK8s, every node is there's only one node, so it is a control plane node already. So all those, there's no need to set a toleration for that. But in an actual production environment, yes, you would need to set a toleration to allow Fluentd to run on control plane. And of course, same for FileBeat. But like I said, for this lab, I don't need to do that. Fluentd, make sure Fluentd has a repository full of images and configs called the Fluentd Kubernetes daemon set repository. And then it has a Debian Graylog ARM64 image. And it's really cool that they actually have a dedicated Graylog image. And the image really just has just differs like this. It has actual code for the Guelph output. And so that's what we have here. The Fluent Graylog host is my host name. The port is the Guelph port, 12202 over UDP. It can be TCP if you want, but just, again, leaving it as default as possible. An important thing here is an exclude path. We don't want Fluentd to gather and send logs of itself. And so this is an exception we have here. We specify a wildcard path to any Fluentd containers that spin up. Well, I have this one commented out because we actually don't use this. This is, I believe, like a default like Docker format, I believe. But the container tail parser type is actually supplied in this config map down here, named container parse override. And this file, fluentd containerparse.conf, is supplied by a config map down here. And the config map contains that other file I showed you where I told Fluentd CRI parser. Yeah, so this is tail container parse override. This is the config map data right here. So all that to say, can I give you a lot of background if you're curious about the nuts and bolts of this? There's obviously a lot more to it. Just trying to highlight a few of the points so that way, I don't just flash through some commands and show you all the pretty lights and you just wonder, how I did it and think I'm magical or something, which I'm definitely not. So, with all that being said, let's deploy this. So first, I want to create the config maps because they don't exist already. So kubectl, well, I have it mapped to K, which is a common alias to make in the Kubernetes world. So kubectl apply. Oh, and also not to mention, kubectl is actually, let me show you. And spelling helps. Kubectl is actually, and I'm not even using bash, I'm using zish. There we go. So K is actually microK8s kubectl because I'm running microK8s, and because I'm running microK8s, that provides all the Kubernetes context and such that I need instead of running kubectl directly on my host. So it's kind of like a two-part alias there. Either way, so kubectl apply file config map file beat, hence if that'll work. So that config map is existing. It exists. It exists in the logging namespace, and it's available for use because the filebeat pod isn't running yet. But once it does, it'll look for this config map in the logging namespace and pull it in and use it. So that's why the config maps have to be. I could put this config map in this. I could put it in the daemon set for filebeat. So the daemon set really is like the daemon set itself, as I showed you before, is just this last part, and the three dashes separate out different objects. But as you can see, every object starts with API version, kind, metadata, and spec. Well, API version, kind, metadata, subjects for role binding. Like these are all individual objects. I could have separate files for each of these, but I kind of lumped all these together because they make logical sense. All of these are prerequisites for the daemon set. And I could very well put the config map configuration, right here in between these two. I didn't just because I wanted to show them separately and how you can apply a config map and such. But yes, just know you can have them separate or all together. I mean, so I'm going to do the same thing for the config map for Fluentd. And what did I? Oh, that's right, CRI parser. There we go. Okay. And they are both, in the logging section. So now let us apply. Let's start with Fluentd, the Fluentd daemon set. It's all created. This, as you see here, the service count, cluster role, and cluster role binding, and the daemon set are created. So you open up K9s, it should be right up. Here it is, logging namespace, Fluentd. And you might be wondering how this pod is able to access logs of all the other namespaces. That's what and I guess I didn't explain this well enough before, I just realized, but that is what the cluster role bindings are for. Because by default, for security purposes, that's why I suggested you separate everything out by namespace. Typically, without any additional permissions, only resources within a single namespace can access resources within that namespace. So this being the idea of Fluentd and FileBeat is that it's a cluster-wide logging application so then it'll need to access logs of everything else. So it's running. Let's go ahead and run the FileBeat one. There's no reason we can't run both. Typically, in a production deployment, you wouldn't run both side by side. There's just no need to. They should all be gathering the same events in the same containers, but just putting it in different formats in different ways. But we're just going to, for this, this is a very small environment, and WordPress is not a very chatty application. So it's not going to really break anything, but if you have bigger environments, you definitely don't want to do too much of this. And we want to make sure that this is running too. Yep. FileBeat, and you can see the pod again has that ephemeral little tag on it to differentiate it. So let's go and see Graylog then. So in Graylog, I have two inputs. I have a Beats input and a Fluentd input. As a lot of you probably already have, you might have a Beats input as well. You can use the same one. I mean, it's as long as it's 5044 and TCP, which I guess, yeah, by default it is TCP. I don't think you can. Might have UDP. I'm not sure. So you can use the existing. You can use your existing Beats input, but for Fluentd, it's Guelph UDP. And so I probably wouldn't mix these. And you might not want to mix these beats with your other beats as well. It just really just depends. But yeah, so Guelph UDP type. And so let's take a look at what we have here. Well, yeah. I'm going to do last 5 minutes. You see, so we already are getting logs in. You can see here, these are the controller, the host path. A lot of these logs are coming from the kind of like helper containers that MicroK8s uses. Host path one. So here's one from. Oh yeah, this is actually a log from FileBeat pod. So saying the message here is non-zero metrics in the last 30 seconds. So it's just kind of like an informational level log, but you can see it's collecting it. And Fluentd has all these different field names, and I will show you actually. let's demonstrate some WordPress activity instead of just showing these helper containers. In order to know what IP to go to, we need to just see what the when you say kubectl get service, and it's just called WordPress. The external IP is what we want to go to. So we're going to copy that and go into our browser. Okay, and this is the default. Again, this WordPress pod is straight from I believe is in the Kubernetes documentation. They use this as an example. So this is all just sample pages. Go back to Graylog though, and we'll scroll down, and yes, we're getting some web traffic results here. Just the basic get of the root page, all the browser, metadata as well, and the get WordPress includes all the stuff. These are just regular WordPress logs, but they're just wrapped around this CRI formatted header that Fluentd is able to parse through. So if we take a look, Fluentd has a bunch of different fields. They have a Kubernetes field that contains this JSON string of all the different Kubernetes metadata, like the namespace, default, pod name, WordPress this, has a container image, all these kind of things. Kubernetes container image. So this actually did go ahead and parse out all these different fields within this Kubernetes JSON map into their own individual fields. So Kubernetes container image, Docker.io, WordPress, Apache is actually literally just this container image right up here. It's just prefaced with the Kubernetes _ string. So all this stuff, it just makes it really easy to do aggregations based on if you have different apps that are front end pods versus back end, or containers versus back end, extra stuff like that, different pod IPs, and then the tag here is just the log file itself. And so I'll go ahead and show you how we're parsing that out here. Let's do through a pipeline. I mean, as big surprise there. I have Kubernetes Fluentd parsing, and it's basically just a flattened JSON. If it has a field named Kubernetes, then flatten the Kubernetes field, flatten JSON, set those new fields to a map, and then prefix all those fields with Kubernetes _. So very basic, but I think very, very, very powerful in order to separate them out like that. So let's look at the same kind of messages, except in the FileBeat stream. And of course, it's not going to be from this input. It's going to be the FileBeat input. So again, the kind of host path controller, metadata here. FileBeat adds all its normal metadata as well. FileBeat _ agent name, FileBeat _ type, all this kind of stuff, versions, everything you're familiar with if you're familiar with FileBeat logging. Quite a lot of information. But then of course, this as well has Kubernetes field maps as well. Container name, Kubernetes labels, namespace. And so it's just all prefaced with FileBeat. And then the log path here. So let's look at a WordPress, some more WordPress activity. Let's just refresh the page. Let me search for WordPress. Oh, so here we go. Yeah. The same kind of thing. Beats type, and then container image name, WordPress this. So all the same kind of information. Ton of information here. You can, the log offset. You can drop. There's plenty of fields to drop, just like with anything. But all the same information is here, except it's in FileBeat format, and it's all coming from Kubernetes. So this is a really slick way to actually get usable logs out of your Kubernetes pods. If I had the resources, I could stand up another a Kubernetes worker node, and because of that daemon set, a whole new Fluentd and FileBeat pod will be spun up to and be sending logs into Graylog. So that's the core of it. This is how you get security analytics from Kubernetes and fairly easy and publicly available information. The documentation is pretty good on this. There's just kind of a lot of it. You do have to kind of sift through a lot, and there's a lot of different use cases out there. Like anyone who's messed with Kubernetes before knows that it depends on how you deploy Kubernetes, whether you use kubeadmin or microK8s or minikube, K3s, all the different ways have all these different ways of doing things. And so you're going to find what works for you. I used microK8s in this sense, but the concepts are still the same. You're going to need a config map that has the FileBeat and Fluentd configurations that you're going to need. And then you just need to deploy those the Fluentd and FileBeat in your cluster. With that, I really appreciate you all being here and coming to my talk. And I really hope you learned something. I really hope that I've helped simplify and demystify log analytics in Kubernetes. Learning Kubernetes has been great for me. It's been a wild ride. It's a super powerful platform. Can be very complicated, especially to beginners. It's not necessarily as complicated as it seems. So if you all have any questions, feel free to reach out to me. Thank you for coming. Hope you enjoy this, and have a good time at the rest of Go. Bye.